I'm not a security person. Everything I know about security, I learned in the last 26 hours. Um, but I'm a software developer. Just to sort of let you know, this is largely a talk aimed at software developers, just to sort of fit the context. This is if you work for a small team. Does anyone here? Or I guess who here writes backend software and who writes front-end software? Okay, that's perfect. That overlap is who I'm talking to. If you got, your API is probably consumed by people on your team. If you're sharing types between the front end and the back end that are sort of complex, then yeah, I'm going to talk about some tooling that we sort of hand built that I think will be interesting. If that's not you, there's 2 more slides which summarize what I'm about to go through. Then you can go sit outside if you want a bit of fresh air. I won't be hurt. So the problem that I want to solve is this. You've got your back end that you define. Your handler. You post to an endpoint. There's a path. You return some sort of JSON probably, and then your front end. You're writing an API client that requests this. This is busy work. There's no reason for us to define this in our back end and our front ends, but often we end up doing this, and keeping these in sync is a pain. You get it all right, you're pretty happy with how it works, and then one of your coworkers renames a field or changes an endpoint subtly, and you don't even notice it until it goes to production and bad things happen. The solution, what I'm suggesting is you write your backend. Sorry, but I'm using Java here. You trigger a little bit of tooling, and then you can call that immediately from your front end. What you get is a completely typed interface with, we're using TypeScript here, so you have your types for each argument and your return values, and no API to write, no types to duplicate, a seamless front end to back end experience. So how does this work? Roughly speaking, your API is defined in sort of 2 core sections. The interface itself is defined in an interface in Java. This defines the methods users can call, the arguments they take, the types they receive, and then the types themselves. These are data classes or records or the types themselves. On the back end, this interface is exposed via HTTP for each of the methods, and then the front end client is where a special sort of tooling comes in. The API itself is turns into a TypeScript class, and then each of our types turns out is generated as an interface. So starting with that last bit, generating types is the sort of scariest concept here. We have a potentially complex class in Java here. We want to turn that into an interface. Luckily, we don't have to do this. This is actually a solved problem in every language that I looked up. There are plenty of solutions out there that will take any number of classes and turn them into TypeScript interfaces. I'm in the Java realm, so we're using TypeScript generator, but or whatever you're using. Just to sort of step back here, I'm using Java in my examples, but all of these concepts can be applied to any language. Ideally, a statically typed language, but generating the actual API itself loosely is iterating over every API service that we have, iterating over every method, and then generating a little bit of code to call that. Ours looks something like this. We use some string templating, not particularly nice to read, but the end result is something like this. This is the generated client that you wouldn't be writing, but you'd be consuming this. And the types look relatively plain. if you look at that fetch call there, that's hitting an API, an endpoint on our backend. And so our next step is exposing that API. And this happens in a similar manner. We iterate over every service, we iterate over every method, and then for each we expose a special endpoint via HTTP over post usually, because we want to handle JSON bodies. Any arguments that come in, we pass from JSON. We then call the real method on our backend, and then the response from that we turn back into JSON and back to the client. This is how something like how we do it at work. I don't really expect you to read all that, but loosely what's happening here is exactly that. We expose and each method, whatever your language you're using, and even if you're with Java, whatever your backend with will look different. But I just put this up to here to say that this is 20 lines of code or something, and it provides that glue to connect those calls and to your backend implementation. So you have this set up. You have your tooling. A story comes in, a Jira task. Your product manager wants you to implement the deleting user functionality. So you add that to your interface. You implement it on the back end, calling your database, doing whatever. Yes, okay, so we are at a security talk. Maybe you check to make sure they're allowed to delete a user. And then we are in the Java world, so we run Maven package, which happens to trigger our API generation, but you can do this using any sort of method you like. And then you call it from the front end. That's it. You have, you can see this takes a user ID. If I returned a special object from this would be all fully typed. And I mean, so this is relatively simple for an HTTP API, but if you're using WebSockets, you can do, which normally are even, in my experience, even hairier to have type safety. You can perform something similar here as well. If you haven't used WebSockets, one sort of significant difference here is that they, instead of a traditional request and response style communication, you have two channels where you make a request, no response will ever come back, but you also have another channel on which messages can be sent from the server to you. So on the left hand side, that's relatively similar, with the exception that that's a one-way communication for clients to make requests. But then on the back end, you have another special interface. In this case, I call them events, where the back end can call this special object. We have a proxy object which handle this. So whenever any messages sent to there will be distributed out to any clients which have registered an interest in special objects, special messages. Here's an example of how that might work. The clients say, I'm interested in any on-message events. The backend that sends a special register message to the backend. And then the backend persists that, remembers that this special client is interested in this type of message. And then at a later point, another client sends a message through a backend, performs whatever sort of processing we need, and then distributes that out to any listener that's registered in intent to, any interest in those types of messages. So the TypeScript for this is also not a little bit less interesting than before. I'm gonna skip over that. The backend handling is relatively similar to what we had before, but WebSockets have a couple of extra cases we need to handle. There's on connect and on close events where you can do maybe user validation and maybe some cleanup if you wanted, and then you need to handle this special register message in addition to your typical method calls that users can make, where you add anyone that calls register for a particular message, you persist in a you want to remember that in case you need to send messages to them later. The event proxy object simply, this is the special object that on the back end you're able to it acts as a proxy for all of the WebSocket clients that are registered in interest in receiving particular types of messages. It simply converts arguments to JSON and then notifies any of the listeners. But the result of all this is a very nice, clear, easy to use interface for your front end. You can send. You can call methods on the button on click there, and then you can register in a callback for any events that come in from the server. So I want to emphasize how great this is. This offers essentially compile time safe from your back end all the way through to your front end with static types, providing the developer experience is sublime. You write safer code. You can write faster. Create features more effectively, and WebSockets are a little hairy, I'll admit, but the HTTP API is not that complicated. You could spin up something like this in a weekend, and your team will love you if you do this. I haven't done it, but I bet you could write an IDE plugin to sort of follow usages and all the way through to your front to back. So in theory, you could see, I love that, this code is unused. I know I can delete that. I mean, you could get that going, knowing that you have no front-end code that calls this as well. It's not perfect. It's not maybe a well-designed API. You might not want to give this to some third parties and say, this is how to communicate with our system. But you can also go a little bit overboard. We have some special annotations that say, only specific types of users can access this. But the WebSockets, you need to think about things like maybe you don't want to echo messages back to the sender. You can go down a little bit of a rabbit hole, but that's sort of up to you to keep things relatively simple. With all APIs, it's easy to break backwards compatibility. This is no different, and in fact, it's just a little bit easier because you can easily just go ahead and rename something and forget that that's actually tied all the way to the front end. And if you deploy, you're going to need to make sure that any of your clients get your latest API client. And you'll also notice, you'll learn all the differences between whatever your backend language is and JavaScript. For example, in the API interface for us, we can have two methods with the same name and different arguments because Java allows method overload. Our tooling will then generate TypeScript for that, and that TypeScript won't compile. So yeah, you'll find out the sort of subtle differences. If you don't want to roll your own, I am suggesting that, but there are other solutions for this. The TypeScript generator that we use will actually generate you an API client if your backend is using a few common sets of tooling there. There's some impressive tool called JSuite, which actually will, in addition to generating you interfaces for your classes, will actually generate the methods in them as well, and will transpile Java to JavaScript. If you're in the TypeScript world, if you're in like a fully TypeScript stack, there are some cool solutions out here. This is one that I found. Any backend file that ends in telefunc.ts, you can just call from your front end. There's no sort of extra transpilation step. It'll just figure it all out for you. There are other options in the TypeScript world if you're on the bleeding edge. If you want your API consumed by third parties, then you might want to look at API. You might be writing your API in YAML, which I'm so impressed with, but there are other options. You can also then generate API clients for many different languages and platforms, which is kind of cool. And then I haven't used GraphQL, but if you have separate front-end and back-end teams, then this is kind of nice, I think. If it lets you sort of have that type safety, but also not have to sort of dig into the backends to generate the sort of data that you're looking. So yeah, I have a question. Has anyone done something like this or used any tooling like this before? Okay, yeah, I want to come talk to you guys afterwards because I don't know, like the company that I work for, relatively small, not code base, sort of nothing to brag about. But this is fantastic. I every day I use this, I'm just so pleased whenever it catches a build failure because I've changed a field or I want to know what data is coming back and I don't have to maintain two different sources of truth. If you want to, this has been sort of a quick overview, but I do have an example in Java generating the HTTP API and one in Kotlin generating the WebSocket stuff. They're very sort of simple, but examples of how they can work on GitHub. If you just want to talk to me about how they work, I would love to chat about this stuff. I think that this is